Hello everyone, in this video we're going to talk about the double linked list operations, pop back and pop front, which means that we're going to delete a node from the very beginning of the linked list, which is going to be pop front, also deleting from the very end of the linked list, which will be the pop back methods. As I have explained in my previous videos, the pop back and pop front operations in a single linked list, we know that the time complexity required to do the pop front will be from the big O of 1. However, in a single linked list, the pop back was from the big O of n. But as we were talking about the double linked list and we have access to the next and previous node, also we have added the tail node, or adding the nickname to the very last node. It should be faster to remove the very last node. So the pop back, we expect to see an improvement into the time complexity of the pop back. So I'm going to start with the pop front method first. So again, we're assuming that we're going to return the data from the type T, and again I'm using the very similar to Java code, so it's going to be the generic class for the linked list with the head and tail to be nodes, and each node has some data from the type T, and then next node and the previous nodes. So the pop front function, and so it has no parameter. We're going to return the node that we're going to delete, which is going to be the head. So again, I'm assuming that the link is not empty. If the link is empty, you can just return null. So let's just write it anyway, this if statement, just to make sure that our code is complete. So if header is equal to null, means that we don't have any node. So it simply returns null, which means that there is no data. In the else statement, we're gonna remove the header node. So just this is the node that we're gonna delete, and that means that, as you see here, this the next node of the node head must be the new head. So that means that I need to get rid of this connection that I have here. So in the else statement, I'm gonna write simply head to be head dot next. So this statement that I have written here simply will remove these two connections that I have here, connection number 1 and connection number 2. Also, we're gonna get rid of this node completely, and we're gonna set this node to be our header node. So again, if you're using some other languages to implement the linked list, so for example, we're using C, we might need to delete the header node manually, but Java will take care of that node, and we don't need to be worried about the memory management and log the references and other or the pointers or any other issues. So that's the pop front method. Again, just a very simple version of that. We might need to check some other stuff or add some more checks, but I think that's complete enough, at least for our purposes. So regarding the time complexity, as you see, the number of operations that we need to do in the pop front is again constant. So the time complexity for the pop front is from the big O of 1. So going to the pop back, and again I'm going to draw the chart one more time. Not the chart, but just the linked list that we had. So here is a linked list, again with head to be the very first node, and then we have the some other nodes here. Let's put the very last node to be the tail. Again, these are the links to the next and previous nodes. So pop back, similar to the pop front, will return the data at location at the last node. I think was one thing I forgot was to actually return the data of the header at the old header. So I think this code is missing something here. I need to keep the data of the header, so I'm going to write header or head data to be stored in the variable called data, and at the end, after changing the like the header, I need to just return the data. I think that's gonna complete my code. I think I've forgotten to add this one because it returns actually something. So t data equal to head.data or data, and then header will be head.next, and then at the end we're returning the data that we have here. So pop back function, as I said, the pop back will remove or delete the very last node, which is tail, and the previous node of like the tail node will be our tail. Okay, so now we're gonna again write if header is equal to null, which means that there's no node exists. So if head is equal to null, then just simply return null. However, in the else statement, as you see here, we're gonna say tail dot previous, or tail must be tail dot previous. Okay, so, and again, before doing that, we need just to make sure that we're storing the data, the data of like the old tail. So data will be tail dot data. Also, we need to make sure that because that's going to be the new tail, it doesn't have any next anymore. So we need to write tail dot next to be equal to null, and at the end we need to return the data. So now that I wrote the pop back, I think again I need to just another fix to our pop front. So because we are saying the head equal to head dot next, so we are still having this head that we create here is still have connection to the previous. So what I had to do, I need to write this statement, which is head dot previous is equal to null. So I have to add this one, so to remove these connection number 2. So this connection number 2 needs to be gone by writing head dot previous equal to null. So I completed the pop front. Again, we know the whole concept, the whole story about the pop front and the pop back, but just want to make sure that our code doesn't have too much bugs. So I think the one that I have written here now works almost fine. So if you look at the pop back method as well, as you see, the number of operations again is a constant number, so we're doing just a few operations, not related to the size of the linked list. No matter how many items do we have in the linked list, the number of operation required to do the pop back is still the same, which means that the time complexity of the pop back operation, or the average, or every case time complexity of the pop back operation is big O of 1. So comparing to the single linked list, and assuming that assuming that there is no tail in the linked list, we see that the pop back time complexity reduced from the big O of n to big O of 1. So big O of 1 for both type of linked list, single linked list and double linked list for the pop front. For the pop back, for the double linked list, it was big O of 1. For the single linked list, it was big O of n. In our next videos, we're going to talk about some other operations for the double linked list, which will be insertion and deletion of like an existing insertion of a new node and deletion of existing nodes.